Okay, before I make these videos, I kind of have like I kind of think about what I'm going to do and I kind of plan it out. Not super serious. I don't have it written down, which I probably should. I kind of just think, oh, I'll do this, and this. And if that one comes up, I'll specify this part and I'll say, oh, that part came up in a certain exam, be careful of it. And sometimes I might twist it around like that. When I was thinking of this one, I just got really just annoyed, like just pissed off because every single person doing this is shit at it, just really bad at it, and I can't for the life of me figure out why. And I think it's just taught to you poorly. I don't know what the crack is in junior cycle. It's for everybody because it comes up in junior cycle, it comes up in leaving cert, it comes up in ordinary, it comes up in honors, um, and there's no real huge advancements on it in honors leaving cert even at that like the highest level. So there's like this whole thing is supposed to be for everybody as far as I'm concerned. There might be one or two at the end that use leaving cert honor level kind of ideas, but it's the same concept. So it'll be good, just good practice. But it's just fractions. You are all really annoyingly bad at fractions, and it's not even that like obviously people can't do maths, and I get that, and I understand that, and I make money from it, so it's fine. But sweet Jesus, if you guys see two fractions and do the I'll just do the arrows, Graham, one more time, I'm gonna lose it because you don't know what you're doing. You heard the arrow one time. You notice this isn't even. I kind of started off as jokey mad, and I've just gotten proper mad. It every time. So I'm doing this, and from now on, I suppose if anyone annoys me, I'm just gonna send them a link to this video because I swear to God. So there's five different elements really that we have to kind of deal with: multiplication, division, uh, addition, subtraction, and equals. If you have a fraction, if it's two fractions being multiplied, divided, added, subtracted, or two fractions that are equal to each other, like a half equals 2 over 4, some shit like that, but it would have x's in it. Those are for the five different scenarios I'm going to run through here. I'm going to start with the easiest. This is actually, I think, the order I'm going to do them in. This is the easiest way to do it. Multiplication is by far the easiest one. So I didn't even get a question down from this because there's no actual question in the actual junior cert or leaving cert that does just multiply these two fractions together. However, the reason why, because it's too easy. However, you fucks still mess it up, so don't do that. If you ever are asked to multiply two fractions together, what you would do is you simply multiply the top two things together and you multiply the two things together. Top by top, bottom by bottom, no arrows in sight, for the love of God. 2 times 3 is 6, 5 times 4 is 20, and you can divide both of those numbers by 2 and get 3 over 10. Now, I know you're saying, oh, Graham, they're just numbers. I can do that. My calculator, shut up, all right? I'm doing this. You do the exact same thing if it was letters. Yeah, like, I mean it, like, okay, we'll do one, right? 3 over x multiplied by x squared plus 7 over 5. I don't know. Oh, look, I'm multiplying two fractions. It's top by top, bottom by bottom. Literally just set it up like this. No arrows to be seen. I don't know. I cannot stress how this is just something that everybody does wrong. Also, something that this one isn't as bad. I don't really mind this one. This one is obvious, or not as obvious. But okay, the other bit's not obvious either. But there's nothing here that cancels in this fraction, right? Everybody kind of says, oh, well, there's an x and an x, right, Graham? So I can cancel them. I can just be like, boom, boom. No, you can only cancel things if they can be cancelled out of every element. So we consider this, and this to be three different things. You can only cancel something out of this fraction if it can cancel out of everything. So you'll notice there is nothing that you can maybe take 3, divide the two top ones by 3. You can divide the two on the left by x, but you can't divide all 3 of them by anything that's actually helpful. So that one just has to stay the way it is. People might not like that, but that's how it goes. Sometimes in leaving cert ordinary level, technically it's honors as well. You might get one that looks like this. What am I trying to do? 2n plus 10, let's say, right? You might get something like that, and you might say, well, that's not two fractions being multiplied together, except you say that with like this confidence, and yet you still fuck it up, right? It's crazy to me, and it's weirdly easier for you guys to envision it as two fractions, because anything that's not a fraction can be turned into a fraction by just slapping it over a 1. This is another thing you argue with me. No, you can't do that. It's magic. You can't just make up bullshit. This is, Graham, come on. You have to be serious. But anything divided by 1 is just itself. So you could, like, 6 over 1. 6 divided by 1 is 6. 7 divided by 1 is 7. A billion. Oh, God. A billion. I regret choosing a billion, I will admit. Over 1 is just going to be a billion. I'm not writing it out again. I know you want me to. But anything can be turned into a fraction just by slapping it over 1, because it would be the same thing. The only reason we can't put in numbers is it would be if it changed it. By dividing it by 1, you're not changing anything. You're just changing how it looks. And then the benefit of doing that is then we can automatically say, well, it's top by top, bottom by bottom. Just like normal. Now, the bottom will just be 2 multiplied by 1, which is fine. But a lot of you just can't do that part either. And that bit's not... I know I'm kind of like annoyed, but that bit's not too bad. Like, I can understand why people don't get that. I just don't like when they argue with me about it. That's the... Now, you'll notice in this one, out of the 3 elements, there are 3 elements in this one as well, because I keep setting up the same kind of question by mistake. Every single one of these can be divided by 2. So what you can do is simplify it down, should you choose. Now, technically, this would turn into n squared plus 5n over 1. But you can just change that to n squared plus 5n. Because, again, in the same way that we can put something over 1 if we want to, we can also just remove the over 1 if we don't need it. The red over 1 at the start, though, we did kind of want so that we could see how to multiply these two things together. But yeah, that's it. So if you're multiplying 2 fractions, top by top, bottom by bottom, if you're multiplying something by a fraction, change it into a fraction. Just put it over 1. And then do top by top, bottom by bottom again. And it's fine. Cancelling stuff out like that works. I will highlight here, while we're on this, it's a different... I'm kind of taking a step out here for a second. This thing can be split up like this. That is allowed. As long as the part you're splitting up is on the top. For example, if it had been the other way around, if we had this, where the 2 parts are on the bottom instead, you cannot split up the bottom bit like that. That is no bueno. That's not allowed. So not that one. Yes, this one. So if you're allowed to split up the top elements, but you're not allowed to split up the bottom elements. Hopefully you all can understand what I'm saying there. That one wasn't one I had thought about when I was doing the pre kind of cursor bit myself. So I don't know how well I've communicated that. I kind of have it in my head what I'm doing, and that just wasn't one of them. So that's multiplication of 2 fractions. Even if the fractions were huge or small, it does not matter. If there's some horrificness like to the nature of the fraction, it doesn't matter. If there's a load of letters, it doesn't matter. Multiply the top by the top and multiply the bottom by the bottom. Happy days. Division. You'll be glad to hear division of fractions, while it sounds horrendous, is actually quite easy. Let's say I said 3 over 7 divided by 9 over 2. The reason why division is easy is it's actually so hard. What we found out instead is you can actually just do it where you do the first fraction, the fraction on top, if you get me, if we consider that fraction like that. Then we can just multiply it by the bottom upside down. So instead of dividing by 9 over 2, we can multiply by 2 over 9, and that's the same thing. That is legitimate. So if you're ever dividing fractions, it just turns into multiplying fractions, and we're experts on that now because we know that you multiply the 2 top guys together and then multiply the 2 bottom guys together, and then you're donezo. That would be 6 over 63, and that can be broken down to 3, that's a brazen lie, 2 over 21. So that's literally it, division. That's all it is. If you're dividing by a fraction, you can flip, even if it's a single number divided by a fraction. I suppose I should do one of those. What about 7 divided by 3/4? 7 divided by 3 over 4? That's gross. I'm not doing it. I'm going to say 7 multiplied by 4 over 3 instead. You just flip the bottom fraction upside down and multiply instead. 7 by this, oh, that's difficult, unless I make it 7 over 1. Aha! figured it out. No tricking me here. And then we do 7 times 4 on top, 1 times 3 on the bottom. 28 over 3. And that one can't be broken down as far as I'm aware, but like my brain is full of rage more so than knowledge at the moment. Yeah, but that's how you do that. Hopefully I don't need to do too many of those, because it is just reverting it back to the multiplication ones like above. The one thing I'll mention as well with this, let's say sometimes you do get fractions that are just numbers. So like for this one you could say, oh well, I could just, that's all numbers, there's no x's in it. Now I didn't do one with an x, I'm realizing, but it's all still the same. I'll do one, I suppose. I'll do one. X over 2 divided by 3x squared over 5. I don't know. That's just the same as x over 2 multiplied by 5 over 3x squared. Just flip the bottom one upside down and multiply instead. Multiplying fractions is top by top, bottom by bottom. So it'll be 5x over 6x squared. And then that can be broken down into 5 over 6x. Now, I didn't really elaborate on that bit, I suppose, with the letters. The idea is 6x squared is the same as 6xx. The power tells you how many times that letter would be written side by side if you were to write it that way. We just tend to avoid doing it. And what you do is you cancel out one of the x's on the top and one of the x's on the bottom. And that's how I knew I was going to be left with 5 over 6x. 5 over 6 doesn't break down, but the letters do, if you follow me. I'm kind of just going to use this this video to just get rid of a few of the nonsense things you do. Another thing you do, actually, 3 divided by 3 is 1. Oh my god, it is not just, oh, they cancel, so there's nothing left, so actually it's 0. No, do not do that. That is not true. It is a 1. 3 divided by 3 is 1. That is something that you all do. Oh my goodness. But Graham, I cancelled them out, and therefore there's no numbers left. So therefore I can just leave, go frolicking through some fields somewhere. No, it is 1. Oh yeah, I was gonna do. Yeah, there's another thing. So back to this. I said originally I was going to talk about how you might say, but Graham, there's no letters in that, so I would just throw that at my calculator and be done with it. Okay, happy days, except you fucked that up too somehow, because these are all just so intelligent. When you're typing this into the calculator, if you want to type a fraction divided by a fraction, to be totally honest with you, I'd advise you to just do this. Right? Just write it like that, because now you can technically write it like this, but everyone messes it up. So I would advise you to write it like that. Let's say you're stubborn like myself and you want to write it like this way. When you do the fraction key, you will get 2 boxes. But what you need to do is you need to put one of the new fraction boxes in here and one in here. That is different than if you just press the fraction button 3 times. If you press the fraction button 3 times, what you end up getting is actually this. I need more room. That's the same thing. You get this. That is not the same thing as this. I cannot think of an example. Well, there might be. I was going to say I can't really think of an example where you're ever going to need this one, so just forget about it. But I think maybe in Leaving Cert Honours there might be once or twice that it has happened. But they are not the same thing. You have to be careful. If you're writing it like this, this is the way you write this, okay? This would be if you had like a half, you need to divide it by 3. So you divide it by 3, but then you have to divide that by 7, which is different to a half divided by 3 over 7. Those two things are different. Be careful when you're pressing the fraction key. Literally put the cursor where the fraction is. I know it's a thing that I'm stressing over here and you're not kind of, not caring, but you know what I mean. You're going to be like, okay, whatever, I'll try it, but if I forget it, I forget it. I'm going to do some fraction. Okay, all right. But yeah, please just be careful. Try to do what I said. Thanks 1,000. Because otherwise, that's division, right? So we have multiplication and we have division of fractions. Multiplication is top by top, bottom by bottom. Division is flip the bottom fraction upside down and it becomes multiplication, and then you just go back to multiplication questions. If there's numbers that can cancel, happy days. If there's letters that can cancel, happy days. But again, if there's more than just one thing over one thing, like up here where there was a 2n squared and a 10 on top, you have to be able to cancel it out of everything. Not just one thing, every element. So 1, 2, 3, have to be able to cancel it out of all of it. Like way up here, we didn't see any that cancelled out of 3x squared, 21, and 5x. Okay, now we're going to do addition and subtraction of fractions. So kind of multiplication and division go together, addition and subtraction kind of go together, and then equals is its own shit show that we'll get to. But if we were to look at this guy, write the following as a single fraction in its simplest form. So for addition and subtraction, you can only add or subtract when you have a common denominator. So for example, if I said to you, what's a half plus a third? What you do not do this. Oh, well, 1 plus 1 is 2, and 2 plus 3 is 5. Do not. That's a big fat X right there. There's no way that's ever going to work. No. What you would instead say is you'd say, well, a half plus a third. What you do is you look at the two numbers on the bottom, and you say, oh, I can turn them both into a 6, right? You could also turn them both into a 12 or a 24 or 108. It doesn't really matter. You can turn them into whatever, but it's easiest if you find the smallest number that they can both be multiplied into. This one would be multiplied into a 6 if I multiply it by 2, and this one would be multiplied by a 6 if I multiply it by a 3. But whatever you do on the bottom of these fractions, you also have to do on the top. Because now effectively 3 over 3 is 1. So by multiplying by 1, we're not actually changing anything. So that's why we have to do it. And 2 over 2 is like 1. If we had just multiplied on the bottom, we'd be changing the nature of the fraction. Like, for example, if I said 1 over 3 and I multiplied on the bottom by 2, it'd be 1 over 6. But that isn't 1 over 3. So by multiplying by 2 on the bottom, we've changed it. If I did 1 over 3 and multiplied on the top by 2 and on the bottom by 2, I'd get 2 over 6. Which looks different to 1 over 3, but if you put it in your calculator, you'll notice it is the same thing as 1 over 3. It's kind of like the idea of if I said to you what's 4 over 8, you would say, well, I can divide both of those numbers by 4 and get 1 over 2. In the same way as we go from here to here by dividing everything by 4, we can go from here to here by multiplying everything by 4. It's the same kind of idea, right? So what we're going to do is, and I'll finish this up here, I suppose. This would be 3 over 6. This would be 2 over 6. And once they have a common denominator, what you can do is one big fat fraction and put the 3 plus 2 on the top, and you'd get 5 over 6. And that would be the answer to 1 over 2 plus 1 over 3. That's how you do it when it's like basic things. That's what you would have done in primary school. But none of you remember that, which is worrying because you're only just out of primary school. So that's cool. Okay, so we're going to have a look at this one, right? We're going to do it. What did I mention? There was a bit of a moment there, so we'll see. I can't remember what I was just saying. But we're going to do this one. This guy here and this guy here, they were both in an actual junior cert exam. So they both everyone needs to know both of them. Now, this is where you generally hit me with the whole butterfly and the arrows and stuff. And it's kind of weird because the odd time people will get it right. So I want to say if you can do it right, keep doing it your way, that's fine. However, I just know a lot of you just think you're doing it right when you're actually not. So I don't want to, I can't say that because I just know some of you are going to just be like, well, I am correct. I know what I'm doing. Graham said I can ignore it. But the idea is, you'll notice, hopefully I still have it in the video where I did that bit up the top with just the numbers. You'll notice what I did was, even though we said it was supposed to be 6 on the bottom, right? 6 was the smallest number that the boat went into. I did also mention that you could use 12 or 24 or 108, and they would have all been fine. But you'll notice that it's easier to just kind of do, this number comes from over here, what's on the bottom of the other fraction. And then this number comes from over here, what's on the bottom of the other fraction. Now, with numbers, that won't always work out to be the cleanest thing. It will always work out. It just won't work out to be the smallest one. With letters, it's what we have to do. Because as soon as you get to like this type of nonsense, your brain gets mushed. There's no way you're going to know what you're doing here. So what we're going to do here is we're going to say, well, for this fraction, what's on the denominator of the other fraction? It's 3x plus 5. So this one is going to get a 3x plus 5 on the top and on the bottom. Just in the same way we did with the 3 up the top, like just with here. And then for the second guy, we'd say what's on the denominator of the other fraction? It's 2x plus 1. So he's going to get a 2x plus 1 here and here. And then when you multiply those out, you know, you'd say 3x plus 5 multiplied by a 2. Now, some of you prefer to have the 2 in the front rather than at the end. That's okay. It doesn't really matter. It's all the same stuff. It's still multiplication. But it's still 2 times 3x is 6x. 2 times 5 is 10. Now, on the bottom, we're not actually going to multiply it out. And the reason why we do this is, and we kind of always advise you not to do this, is because it's easier to do it this way to see if stuff will cancel out later on. Now, I don't think either of these actually that does happen for, but like, let's say, for example, we ended up with x plus 3 on the top. If one of our brackets on the bottom was x plus 3, then we could say, oh, well then, that cancels with that. Now, it doesn't disappear completely. There's still a 1 on the top. You can't just get rid of the fraction. You can't just say, oh, well, if the top is gone, then there's no fraction anymore, and the answer is x plus 2. The x plus 2 still has to be on the bottom, so it's 1 over. You can't just promote the denominator to not be on the bottom of the fraction anymore just because there's nothing kind of left on the top. It's still a 1 over x plus 2. So that's why we don't multiply at the bottom, because if we had, let's say we had that fraction, we had x plus 3, and we had multiplied out the bottom, if you multiply those two brackets together, you'd get x squared plus 5x plus 6, and then you just wouldn't know that things cancel, and you just leave it like that thinking you're, you know, God's bravest little warrior, right? But no, you notice leaving the bottom bit not multiplied out makes it easier to cancel things later on. So, oh my god. So, do not multiply out the bottom bits. I know you're weirdly going to be arguing with me on that. Sorry, I'm going to multiply out this by this and then this by this. So 3 times 2x is 6. 3 by 1 is 3, you know. You're weirdly going to argue with me on that, even though I'm literally telling you to do less maths. There's just something in you that is like, well, I have to argue with Graham, no matter what he says. Now, like up here, you see the way we had a 3 over 6 and a 2 over 6, and we combine them to be like just 1 over 1, 6. We're going to do a similar thing down here. We're going to do one massive fraction with a 3x plus 5 and a 2x plus 1, but we only write it out the once. We don't have to write it out twice, just the once. The top bits get morphed together on the top. Now, because there's a minus in between these two fractions, we're going to put the 6x plus 3 in a bracket. This is the bit that everybody gets wrong. The reason why we have to do a bracket there is because the minus was on the fraction. It was not on the 6. It was on the fraction. So when we whip it up to be just for the top thing, if we didn't write the brackets, everyone just goes, oh, the minus is just on the 6x and the 3 is a plus. But that's not true. They both have to be minused. So we have to do it like that, because if you remember, there's like a sneaky 1. If there's no number in front of a letter or a bracket like that, it's like a sneaky 1. There is a way of turning off the microphone and stuff, but you can get fucked if you think I'm figuring that out. Yeah, so if there's no number in front of something, it's like there's a sneaky 1. Put the 1 in there. You multiply minus 1 by 6x and then minus 1 by 3. Hopefully yours are okay with what I'm talking about. The 6x plus 10 is still chilling, but it means that this would be minus 6x minus 3. And if we go back to where we hadn't drawn the brackets out in the first place, you'll notice it would have looked like minus 6 plus 3, which is incorrect. So that's why we have to do all that nonsense. Yeah. So then you'd end up with 3x plus 5 over 2x plus 1 on the bottom still. That's fine. On the top, you notice 6x minus 6x cancels. 10 take away 3 is 7. You're left with 7 over 3x plus 5. Now nothing cancels, but that's okay. We still don't multiply out the bottom bit. We're just going to leave it, and that is our answer. Happy days. Happy days. And that's it. That's how you'd subtract two fractions. Hopefully you're okay with that. Because if you're okay with that, the only extra element to it, let's say it had been a plus in the question here, instead of a minus, that's all. The only difference would be this is a plus, this is a plus 1, and then when you multiply a plus 1 by a 6, you get a plus 6x, and then a plus 1 by a 3 would be a plus 3, and it just changes what the final answer down here would be. It would be 12x plus 13 instead. That's all that would change. Hopefully, you're okay with that. I'm not going to do it out fully with a plus in place. There is one later on that does involve a plus, but we get to him in a second. He'll cause confusion if I just jump into him straight away. So I will do one with a plus, but just keep in mind that it is literally the same kind of concept. Will be grand, right? Now, this one, same kind of deal. It was just a different junior cert question. We're minusing two fractions. There's letters on the bottom. I don't like that. So what I'd say is for this fraction, what's on the bottom of the other fraction? It's a 2n plus 5. So this guy gets a 2n plus 5 on the top and on the bottom. This fraction, what's on the bottom of the other one? It's n minus 3. So he's getting an n minus 3 on the top and on the bottom. Whoops. Then multiply 2 by 2n plus 5. You get 4n plus 10. On the bottom, we're just going to not multiply them out again. Don't forget, we need to leave the denominators as unfinished kind of as possible. Then 5 times n minus 3 is going to be 5n minus 3. 15, I completely lied. Minus 15, because 5 by n is 5n, 5 by minus 3 is minus 15. Sorry for goofing that up. And then the denominator is just going to be, again, these two guys not multiplied out. But now you'll notice what's on the bottom of this fraction matches what's on the bottom of this fraction. They both have a 2n plus 5 multiplied by n minus 3. So we get to mush them together as one big ass fraction. Again, we're only going to write it out once on the bottom. And on the top, we're going to do 4n plus 10 minus 5n minus 15. The minus is in between the fractions, so the minus goes on top, or goes with what was on top of the second fraction. It's everything. It's not just the 5n, so that's why we need the brackets. Again, like there's a sneaky 1 in here, and then we multiply by these two things by minus 1. What we end up with is the 4n plus 10 is still fine. Then you go with minus 5n plus 15. When you multiply minus 1 by this and minus 1 by this, you still have the same bit on the bottom. But then on the top, you'd get minus 1n plus 25. Yeah, I think that's right, yeah. Over 2n plus 5 times n minus 3. Now, the problem is, again, nothing cancels here, which is fine. It's okay. I was kind of hoping that one would to show you what I was talking about earlier, but it's okay. But yeah, I can't stress enough, again, that idea that if you had 3 over, like, 6x, and you say, well, that, you know, that breaks down to a 2 on the bottom, it's still just 1 over 2x, right? Don't just think that you get to just get rid of the top bit, right? It doesn't, that's not allowed. It's still 1 over 2x. Now, the thing about this is, those are the two answers, or the two questions answered. Goodness. But basically, this bit here and this bit here, the question and the answer are actually supposed to represent the same thing. They're supposed to represent the same number. So, and the rainbow pen kind of indicates that you don't actually do this part in the question. You, like when you're doing it in the exam, they're not looking for this part. It's me just kind of explaining a handy way if you have time at the end of the exam, just to check that you're right and you didn't goof up. What you can do is pick a number, right? I'm going to pick x to be 1. So in the question, if I wrote that out again, everywhere I see an x though, I'm going to put a 1 in a bracket instead. And I just picked 1 because it's probably easier to do, do you know what I mean? That's all I'm doing. And that would be, that's going to be 2 over 3 take away 3 over 8, which you would do in your calculator. But then that's going to be 16 take away 9, which is 7. I think that's going to be 7 over 24. So if you subbed 1 into everywhere you saw x in the question, you get 7 over 24. Now, if I sub 1 in everywhere I see x in the answer, I would get 7 over 3 times 1 plus 5. 2 times 1 plus 1, which would be 7 over 8 times 3, yeah, which would be 7 over 24. So because those two match, I know I've done it right. So they just said rewrite the following as a single fraction, right? So basically the answer in the question should have represented the same thing. So pick a value for x, sub it into both, try them both on your calculator. You should get the same answer for both if you've done it right. Again, the rainbow pen just kind of indicates though what you would have done, or not what you need to have done for the question, but just to check that you're right. If you have time at the very end of the exam, come back and give that a shot on your calculator and just see if the two things work out to be the same. If not, you might have made an error. And if you have time at the end of the exam, just try it again. If you did get an answer though, it probably means you did the method right and you just fucked up a number somewhere, which isn't a huge amount of marks. But if you have 20 minutes at the end, give it a shot. Just kind of redo it, rehash it out. It is only a one-off exam. Like, don't be like, here, couldn't be arsed. Just give it a shot. Again, this guy would have been ever so slightly different if it had been a plus. Instead, this would have been a plus, 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 and this would have been a minus. And then the answer down here would have been 9 and minus 5. Ever so slightly different. That's all. Very minuscule, the difference. So keep that in mind. And also, this would have also worked if I had wanted to just cordon this guy off and cordon this guy off. And then pick a number for n. Maybe 3. Doesn't matter. Well, don't pick 3, actually. That's another thing I should have mentioned. You can't pick a number that would give you a 0 on the bottom of the fraction. The calculator would freak out. So my problem with picking 3 there would be the first fraction would be 2 over 3 minus 3, which would be 2 over 0. But that is not allowed. You are not allowed to get a 0 on the bottom of the fraction. So if your calculator says error, I suppose just pick a different number and try it again. That's probably what I should have just said. Okay. Hopefully that's okay for minusing two fractions. And if you want to check it, use the rainbow pen kind of method way that I just did there to check. Yeah, otherwise that's subtraction. And I'm also going to consider that counting as addition as well, because we saw there's very minor changes, but I will be doing one over here as part of this question when we get to it anyway. So if you do want to see an addition one, just kind of have a look at that one. We're going to have a look at this one though, because it's now, this looks horrific to everybody, I suppose. The anomaly of letters just kind of thrown around the place. Don't really worry about that for now. I just kind of, it was the only time I saw in an actual question fraction equals fraction in an exam question, so I just kind of grabbed onto it. The idea all stems from though, imagine you had x over 3 equals 7. How you would deal with that is you would multiply on both sides by 3. The reason being, it's we want to get x on its own, so we don't want there to be a dividing by 3. So to do that, we'd have to do the opposite of dividing by 3, which is multiplying by 3. Because multiplying by 3 and dividing by 3 are the opposites, they would cancel, and we get left with just x on this side, and on this side 7 times 3 is 21, and we get told just x equals 21. If you had a fraction like that, to counteract it, you'd multiply both sides by the denominator and just get the maths dealt with. That same thing applies if, imagine we had x over 3 is equal to, hang on, x plus 2 over 5, right? Yeah, that works, yeah. So imagine you had this, again, what I would do is, now there's two fractions, but don't get scared. I'm just going to look at this one for a moment. What I would do to get rid of the 3 is, it's a dividing by 3, so to do the opposite, I'd have to multiply both sides by 3. So I'd do here and here. And this would cancel. Now what way do I want to write this? So I'd be left with x equals x plus 2 over 5 multiplied by 3. But here I want to get rid of the dividing by 5. What's the opposite of dividing by 5? It's multiplying by 5. So I'd multiply on both sides by 5 now. And then what would happen is here and here it would cancel. And we just get left with 5 multiplied by x is equal to x plus 2 being multiplied by 3. No fractions, and it just becomes algebra that is doable. I will highlight though the x plus 2 over 5. When I got rid of the 5, I put the x plus 2 into a bracket, because otherwise if I didn't have the brackets it would look like only the 2 is being multiplied by the 3. If I didn't put in these brackets here and here, you notice it looks like it's just the 2 is being multiplied by the 3, but the whole fraction was being multiplied by the 3, so we have to put it in so we know it's the x and the 2 are both getting tripled. And then it's just algebra from here, and we'd multiply out the brackets and we get 5x equals 3x plus 6 Bring the 3 over, make it a minus. Yeah. So 5x minus 3x equals 6. 2x is equal to 6. Divide both sides by 2. You get x equals to 3, right? So that is how you would do it. If you had two fractions, that's how you do it. Now, the thing is, if we had the exact same question over here, x over 3 equals x plus 2 over 5. If you kind of scoot back, you'll notice that is literally the original question that was here. So what some people do is, instead of doing it by multiplying by the 3 first and then multiplying by the 5 second, they do it all at once. And that's how I would do it. I would say there's a 3 on the bottom and there's a 5 on the bottom. So I know I'm going to eventually end up looking like this, where I have the two of them done at the one time. I would cancel out the relevant things. So the 3 here cancels with the 3 here, and the 5 here cancels with the 5 here. And you notice we get left with the same nonsense. If I get rid of them, guys, we're still left with 5 multiplied by x, and we're left with x plus 2 multiplied by 3, which is the exact same maths, but some people would just do it like that, just to make it quicker. I know I've cheated a bit to make it look even quicker by erasing the stuff, but it's just people will do that to make it quicker, right? Now that's where, this is my problem. You guys will hit me with, oh yeah, no, don't worry, Graham, we have our own ways of doing that. We do the arrows. But the thing is, they taught you 2 different ways of doing arrows. They said this way is arrows, but they also told you this way is arrows, but this arrows is different to this arrows, but none of you guys know why. And what's even more disturbing to me is some of you draw the arrows like this, which is just not correct. That's just, it's just wrong, and it pisses me off no end. But I can't hurt your little feelings, because technically you're children, and technically I'm a grown man, and I should know not to bully children. But I'm gonna do it anyway. Can't stop me. But the idea is, this kind of transcends to over here. Now this is by far very complicated for maybe junior cert level. Look, everyone would argue this is kind of complicated, but in this question it said express k in terms of, that just means get it so that at the very end we have k equals, right? And then any old shite can be on this side. This could just be like horrificness over here. It doesn't matter as long as just k equals. Now, in order to do that, we need to get rid of the fractions. How do you get rid of it? If there's a divide by h, we're going to have to multiply both sides by h. So that's okay. And then if there's a divide by j plus k, we're going to have to multiply both sides by j plus k, because that's the opposite of dividing by j plus k. A lot of you might freak out about the letters, but just think, what would I do in this scenario if they were numbers instead? I would have just carried out the same way I did it above with the rainbow pen. So I'm just going to do it out here just with letters instead. Gonna cancel out the relevant things. Here the h will cancel with the h because you're multiplying by h, but you're dividing by h. They are the opposites. They are gone. Here we have a j plus k that we're dividing by, but also that we're multiplying by. They are gone too. What we're left with is j plus k multiplied by 1, the top of the fraction that's remaining. And then we're also left with k multiplied by h. We end up with j plus k equals kh. Now, for the purpose of the fractions, that's it done, right? I just kind of wanted to highlight the idea that if you have a fraction equal to a fraction, you just multiply on both sides by both denominators, cancel out the relevant things, and just becomes algebra. If you are leaving cert honors and you want to finish off this question, you need to get it to be k on its own. So what I would do is I'd bring him over here, because we want to kind of have the k's on one side. So we'd have kh minus k. Now the thing is, we want it to be k on its own, so we should try add these together or subtract them, I suppose, but we don't know how to do that because they're not like terms. This is a kh and this is a k. Can't subtract them. If you can't add or subtract them, but you want to kind of unify them into a single k term, the trick is you take out what's common. If you take out what's common here, you'll end up with k multiplied by h minus 1. The reason was, if you remember taking out what's common from junior cycle, because if you multiply it back in now, if you multiplied k in here and k in here, you'd end up back up at that line. So therefore, you know, we could go from here to here, but by that logic, we can also go from here to here. That's allowed. And we still have j just chilling over here. And how would you get k on its own? You divide both sides by h. Yeah, I'll do it here, I suppose. Divide both sides by h minus 1. Here and here. Because then these would cancel and you're just left with j over h minus 1 equals k. That doesn't look familiar, I'll be honest. I don't know if I scuffed something up slightly. J plus K by H is cancelled, J plus K cancels, KH, J plus K. I didn't fuck up the red bit, I don't think, anyway, which is the important part. I think everything else is fine just looking at it. I don't know. This is the third video I'm making today, so I might have made a mistake somewhere here today. Let me know. Let me know, but don't try to be gleeful about it. Do you know what I mean? Don't just be like, oh, he's finally fucked up. Now I'm going to get him. You know, or else I'll cry. So don't do that. But hold on there now, buddy. What's happening here is after going on a big spiel about don't bully me if I made a mistake, in this next bit I'm about to do, I do make a mistake. Now, in it, you're going to hear my little heartbreak, but I left it in it because I will explain numerous times why I left it in it when we're doing it, but I just think it was more beneficial, and to be honest, I just couldn't give a shit to go back and take it all out. So, yeah, if you're going to do this next bit, do not take it down straight away, because I do make a mistake and go back and fix it. I multiplied two numbers wrong. But hopefully, previous Graham will explain it decently enough. Alright, peace. This one, I can't remember where I got this one from. I think it was an ordinary level leaving cert. I do think. You'll notice that there's three fractions with an equals and a plus, right? Now, there's two ways we can approach this. We can approach this question equivalent to how we approach this one, where there's a fraction equals to a fraction, or we can approach it equivalent to one of these two. And what I mean by that is we can either do, I'll do it two different ways, right? I'll do it like this. I just feel like the pen was maybe a bit too thick for writing it out. So you'll notice here the denominators were 2, 3, and 4. In the same way that over here the denominators were h and j plus k. So I multiplied on both sides by j plus k and h and just cancelled out the relevant things. In the same manner, what I could do here, and this is the way I personally do this, but if you don't like it this way, you can do. I'll do it in a second way in a second. You'll be able to see. I would multiply literally everything by 2, 3, and 4. There's actually a quicker way of doing this too, but what I would do is I'd multiply each of these by 2, 3, and 4. So what I'd end up with is 2 times, now it's going to take me a minute to write this out, so just bear with me. 2 times 3 times 4 in front of the first fraction, then equals, and then I'd have 2 times 3 times 4. It's just, there'd be people who just think you can just skip a certain part of this that I don't even want to bring up in case it introduces the idea of skipping it to them. Just out of a lack of practice and a lack of, I understand, I get why. But you notice that each of the fractions gets the 2, the 3, and the 4, because if you're multiplying the whole line, each of the parts gets multiplied by it. You cancel out the relevant bits. So here the 2 cancels with the 2. Oh, is this one not changed? Okay. 2 cancels with the 2, the 3 cancels with the 3, and the 4 cancels with the 4. You just cancel out the relevant part, and you're left with multiplication. Now, you're multiplying three things together here. You're multiplying a 3 by a 4 by a 9x minus 6, if you think about it like that. Don't try multiply all three things out at once. It's just going to cause confusion. Multiply two things together first. So, for example, here 3 by 4 is 12. And then multiply that by the third thing, which is 9x minus 6. And then that would be 108x minus 72 when you multiply the 12 in here. Here, we're going to do a similar thing where I'm going to do 2 times 4 is 8. But I'm going to multiply that by the third thing, which is 3x minus 14. And that would be 24x minus 42. And then a similar thing here where 2 times 3 is 6 times 9x would just be plus 54x. The plus just being the plus from here. Hopefully you're okay with that. And then it just becomes algebra. And we'd move all the x's to one side and all the numbers to the other side. So 108x minus 24x minus 54x. Now again, some people do that differently where you'll minus 24x from both sides. Like you instead of doing that, you would have minus 24x here and minus 24x here. That's okay too. If you're doing it that way, that's fine. Hopefully you get the same answer as me, and you can just check at the end just to make sure. And then over here we'd end up with plus 72 minus 42. This is going to be 78. 30x equals 30. That's weirdly okay. And then you divide both sides by 30, and you get x equals 1. And that would be your answer. Now for these ones, when there's an equals in it, now I couldn't do it the last one because it was an equals, but there was all letters, there was no numbers. Here, because it was an equals and it was x equals 1, to check your answer, right, rainbow pen job, right, what you do is you take the 1 and everywhere you see an x up here, you replace it, you replace the x with the 1. Hang on, let me just make sure I'm actually recording it. Yep. I think I'm recording it right. I'm going to be raging if I'm doing this wrong. So what you would do is you'd say 9 times 1 minus 6 over 2, and you'd put that in on your calculator, and what you would get is 3 over 2. And then there would be the equals, which is kind of like a break, and then you'd write the right hand side with a 1 in place, and you'd say minus 14 over 3 plus 9 times 1 over 4, and you would just put this whole thing in on your calculator, right? And hopefully it'll be 3 over 2, and it would be minus 11 over 3 plus 9 over 4 should be minus 33 plus 36. Yeah, it would, hold on, 3 over 4 actually. Am I getting something wrong? Oh, minus 40. Hang on. Okay, so I did make a mistake, right? Now I was thinking, I kind of personally just laziness, don't want to go through it, but we can kind of use this as a learning exercise, right? So I did make a mistake, and I'll show you what the mistake is in a second. But we got x equals 1, right? Even if I hadn't spotted that was wrong, I still would have gotten at least 7 out of 10, if not 8 out of 10. It depends on how the market scheme works. But that probably, yeah, maybe 8. So don't be too disheartened if you get to an answer that's incorrect, because I also did it. Now, what I did wrong here was, and I only knew I was wrong because when I do this on the calculator, it is not 3 over 2. So that means that x is not 1. So something has gone awry somewhere, and I was just having a look, and it might annoy you that I'm doing it this way, because you probably might have taken it down. Maybe I'll put in a, do I try to put in a warning? Maybe. Yeah, okay, I'll try to figure something out. But basically, here, where I did 8 times 3x is 24x, that's fine. But then instead of doing 8 times 14, I did 3 times 14 in my head. So my apologies on that. What is 8 times 14 would be 112. So then instead of 42 here, it would have been 112. And then here, instead of 30, so we'll get rid of all this. So we would have had 30x on the left. That bit's still okay. And we'd have it equal to minus 40. And we divide both sides by 30. And we get x is equal to minus 4 over 3. So now what I'd advise doing is going back up here and everywhere, instead of putting 1 in, put 4 over 3 in everywhere there's an x. And seeing if that works. So in a weird way, I'm kind of abusing the fact I got it wrong, and we're going to actually check to see. It kind of shows how to check and how that can actually work out helpful in a way. I know it's not ideal. I get you. I obviously didn't want to make that mistake myself. But it does happen. It happens. Don't get too disheartened when it happens to you guys, because you guys will get 8 out of 10 or so. Yeah, so what I'm going to do is I'm going to do the same thing that I just did. I'm going to take the left-hand side of the kind of rainbow vertical line. I'm going to throw it in my calculator. And I'm going to do the right-hand side and throw it in the calculator. And just see that it is correct. Now, it is minus 4 over 3 before I dip. I didn't realize that, of course. It's not 4 over 3. It's minus 4 over 3. Okay, I'm going to try that and we'll see what's what. So yeah, when you notice now, if you type in the left-hand side of that into your calculator, you should get minus 9. All of this should be minus 9. And if you type this into your calculator, it should also be minus 9. And they're the same. So actually, minus 4 over 3 is the correct answer. And you notice the one was gobbledygook. I only figured out I'd made a mistake due to the subbing it in method, right? Okay, now so it's kind of just that I'm too tired and too lazy to go back and do the whole thing again. I really should have just cancelled that and wipe it and start again and do it from fresh. So I'm going to, hopefully you're okay with me. I will have hopefully tried to figure out a way of just me kind of warning you ahead of time. Not to kind of go wholeheartedly into that one, because I do make a mistake. But at the same time, I don't want to get rid of it out of laziness, as I said, but also it highlights how you can kind of see if you're wrong. And also, I do want you to recognize that you still get 8 out of 10, even if you had done it the fucked up way that I did it the first time. Yeah, and as well as that, I'm going to do this out 2 other ways anyway, so I didn't really see what we're going to see. Well, it's not that I think I'll be doing it too many times. Hopefully you're okay with that. Part of the thing about the videos is I'm more used to having one of you sitting in front of me, and I can kind of get feedback from you directly as to whether it's good or bad or indifferent, or whether you're okay with something, or whether I've done something. So this is just a stream of my consciousness, so it could be that I'm just saying shit that you guys are just not okay with. So I don't know how you're going to feel about that, but hopefully it doesn't rustle too many jimmies. Hopefully we'll be okay with this. But we'll see. I'm sure I'll hear about it if anyone actually watches the stuff. So let's say we have the exact same question. Now I'm just going to check I've taken it down right, because I have goofed a couple of times. Yeah, the exact same question. Another way of doing it would be, instead of doing 2, 3, and 4 all together, what you can do is, what number can 2, 3, and 4 all divide into? The smallest one would be 12. The biggest one would be, well, no, a bigger one would be 24. You could have 36. They would all be fine. So you could pick any of those. I'm going to pick the 12, because your aim is always to find the lowest one. So that would be the lowest common multiple, because it is common to all 3 of them. But 12, again, you could use any of these. You could still keep going and use 48. You could use 60. It doesn't really matter. But 12 works. So what I'm going to do is, instead of multiplying every single one of them by 2, 3, and 4 like I did in the previous method, the previous method was still legit, just I did fuck up multiplication. I can just multiply each of these fractions by 12 instead. It'll just be... now, some people might not like this way, and that's fine too. We're going to see that we end up with the same equation anyway. Now, the thing is, though, when you're doing this, you notice I'm multiplying everything by 12 because it's the lowest common multiple of all the fractions. But instead of doing the 9x minus 6 divided by 2, I'm going to do 12 divided by 2, if you get me. I'm going to kind of treat that as 12 over 2. 12 divided by 2 is 6. So that 12 and that 2 kind of cancel to just have a 6 in front of the 9x minus 6. Like so. If you don't like this way, stick with the other way. It's not too bad. 12 over 3 would be 4. So I'm going to treat that as a 4 in front of the 3x minus 12, or 3x minus 14. The 12 and the 3 are kind of irrelevant now, just gone in my mind. And then over here, 12 divided by 4 is 3. And that would be in front of the 9x. Then that would be 54x minus 36 equals 12x minus 56 plus 27x. Again, we move all the x's to one side, all the numbers to the other side, so we'd end up with 54x minus 12x minus 27. Again, some people would do that differently to how I would have done it. They would have taken away 12x from both sides and been left with this. Well, with what I'm going to get next. Again, try it your way and just make sure at the end you get the same answer as me. Although I did say that the last time and then I goofed it up. So, who knows? Maybe we're all screwed. This would be 27. This would be 15x equals minus 20. You divide both sides by 15. And you get x is equal to minus 4 over 3 again. So that's another suitable way of doing it. It's kind of like a short, it's not really shorter, but what I mean is the 2, 3, and 4 are kind of like abbreviated into a 12, but there is an extra bit of kind of thinking to do. So it doesn't matter which of these two ways to do it you prefer. Yeah, now I'm going to do it another way, because those two are very similar, those two ways. It just depends on whether you like the 12 bit or whether you like the 2, 3, and 4 bit. So over here, now what I'm going to do over here is, even though the question is in equals, I'm going to kind of treat just the bit on the right first. So you notice it's a plus on the right hand side. So what I'm going to do is what I did earlier, where I did the two fractions that are being minus from each other. I'm going to kind of zoom in on this and just do this one first. I'm going to kind of forget about your boy over here for a second. So I'm just going to get rid of him for a moment. And just kind of look at this. I know that's very aesthetically horrific to me anyway. I'm assuming some people are going to be happy about that. But oh look, we're adding two fractions together. So this would go back to the subtraction of two fractions, where what you do is you'd say, well, for the left-hand fraction, what's on the bottom, for this guy, what's on the bottom of it? It's a 4. So we're going to multiply top and bottom over here by a 4. And then for this guy, what's on the bottom of the other one? It's a 3. So I'm going to multiply top and bottom here by a 3. Now, you'll kind of see why I'm doing this hopefully now in a second. If you do that, 4 multiplied by the top of that fraction is 12x minus 56. 4 times 3 is 12. 9 times 3 is 27x. 4 times 3 is 12. Now, some of you might see that some things cancel out here, but we don't want them to cancel out because we did this on purpose. We made it look like this on purpose so that the bottoms match, right? Because if you remember from the subtraction, when the bottoms match and you're adding or subtracting, you can morph it together as one big guy. 12x minus 56 plus. Now this is where we would have done the bracket to 27x because it's on top of the second fraction and put in a sneaky 1. But because we're multiplying by plus 1, it doesn't really make a difference. We'd end up with 12x minus 56 plus 27x over 12. That's a 3 over 12. Add and subtract and do all, tidy up the top bit, and you get 39x minus 56 over 12, just adding the like terms together. Now that we've kind of taken the two guys here and morphed them into one, we're going to reintroduce the OG guy that we forgot about, this lad on the left. So imagine he had just been like here and here and here, and now he's down here again. So I just don't want to write it in the whole way down. You're technically supposed to write 9x minus 6 over 2 equals, you know what I mean, the whole way down. Here and here as well. I'm just going to write it down here out of laziness in your exam. Do not do that. Well, you can. Actually, in your exam, literally, you can literally just ignore this for the moment and just write it in down here. But now, so at the start, we basically took these two lads and turned it into a plus. But now we're going to take these two lads, ignoring all the rest of the maths, and just pretend it's two fractions equal to each other. And what did we say when we did equals? We went back to here. We multiplied on both sides by the denominators, and they just cancelled out in the relevant spots. So here's a 2, here's a 12. I'm just going to multiply on both sides by a 2 and a 12. Because here the 2's cancel, and here the 12's cancel. And we're left with 12 multiplied by 9x minus 6 equals 2 times 39x minus 56. Then that's going to be 108x minus 72 equals 78x minus 112. We bring all the x's to one side, numbers to the other. That would be 30x. This would be minus 40. Again, we divide everything by 30. And we get left with x is equal to minus 4 over 3 yet again. Now you notice this way is longer. That's just because it is longer. There's no real ifs, ands, and the buts about it. I suppose there's just less work to do each time. But some people just prefer that. So there's 3 different ways of doing it. Yeah. Okay, so that's kind of all the things. What I will do is I will redo this now again from scratch. Just the proper way. I just feel bad about it. I'll be honest with you. I guess I'm just feeling more tired than I was kind of expecting. And as a result, I kind of feel like this video wasn't as clear and concise as the other ones I've done. But it'll do for now. If I kind of go through a lot of other topics and I feel comfortable enough with those ones, then I can come back and like do this properly. Hopefully you guys are okay with this. Hopefully you don't think of it as too much of a shit show. But I will do this out again. Like, you know, there's a lot of scribbles and shit on it. Maybe you aren't happy with that. So I'm not overly thrilled myself. So I will just do it out. I won't really necessarily explain it as much because hopefully the explanation will have happened or would have been okay for the last one. I'm just afraid that you guys were going to take it down as I was doing it and just kind of go, what the fuck? But like, it's not too bad. It's the right method. If you guys are in the exam, you won't have me fucking it up. You'll have yourself fucking it up. But try to avoid it. Try use the calculator. But the whole premise of this way was to multiply everything by 2, 3, and 4 because they were all the denominators. I didn't leave myself an awful lot of room, of course, because I am on a roll. Now you can put them on the other side as well if there's more space. It makes no odds. Some people might not like that, but that's just how life does be. The 2s here would cancel. The 3s here would cancel. The 4s here would cancel. Now, the idea that I stated earlier, that if you're multiplying it, there's thing 1, thing 2, and thing 3. Don't multiply all three things together. That still holds. Multiply the 2 together. So I'm going to say 3 by 4 is 12. Multiply that by the 9x minus 6. Then I'm going to do equals. Then I'm going to do 2 times the 4. I know it's a bit squashed. I apologize. Multiply by 3x minus 14. That's a minus 14, but I call good. There we go. Okay. I'm not going to cry as much. 2 times 3 is 6. Multiply by the 9x. 12 by 9 is 108x. 6 by 72. I'm just desperate not to make a mistake here. 24x minus 112. 54x. If I make a mistake the second time, I'm going to be raging. 108x minus 24x minus 54x equals 72 minus 112. Again, that's going to be 78. That's going to be 30x equals minus 40. Divide both sides by 30. And you do get x is equal to minus 4 over 3. So, my apologies for goofing up the first one. But I do think it's important for me to leave it in there because I want you guys to see even I can still make mistakes, so you guys can definitely make mistakes. We saw how to check for the mistakes, right? We can take advantage of that. Me fucking up, we're gonna turn it into, what did Bob Ross say? Turn it into something nice. I can't remember. And we're going to take an advantage of the fact that I goofed up. We're going to take an advantage of it, and we're going to make it so that we know how to fix it, or check that it needs to be fixed, I suppose, in the first place. But we're also going to recognize that even if I just left it as the x equals 1 and just run out the door, I still got an 8 out of 10 for that, right? So don't ever kind of just stop based on you get a horrific number that you're not a big fan of. But yeah, fractions. I was really annoyed starting it, and now I'm really tired. So it probably, I'm going to look back at this, is probably one of the videos I look back on and I'm like, oh Jesus, okay. But yeah, multiplying it, dividing it, subtracting it, and then we also saw one over here where it was addition, but they're very similar. It's just watch out for the minus, right? Because people will screw that up. Equals, if you're doing a fraction equals to a fraction, you multiply both sides by the denominators, both of the denominators, and you just cancel out the relevant things. If you have 3 fractions involved in an equals, you can also do it that way, similar to here where we multiplied by all the denominators. Here we multiplied by all the denominators, and it still worked out. I fucked up some multiplication, but it still works out. You'll notice I just repeated it down here and it was fine. You could do it this way as well, where you find the lowest common multiple of the 2, 3, and 4, which would be 12. You could have used any of those numbers as well, it's fine. And then treat it as 12 over 2, 12 over 3, 12 over 4. Or here you split it up where you do the plus bit first, make that into a 1 fraction, and then bring the equals back into it, and then multiply both sides by the denominator on both sides. Most people, I'd be honest, prefer this middle way. Probably because it looks the shortest the way I've written it, so that maybe that's what it is. Okay, I'm going to try to see how I'm going to edit all this together, alright? Hopefully it's not too much of a shit show. Hopefully it'll do for the time being, alright? Because I just don't want to have to sit down and do it again. There's other things I have to do first before I can do that. Alright, okay, you don't care.